2018. So the graph of the continuous function g, which is the derivative of the function f, is shown above here. The function g is piecewise linear function, okay, so that's given. And then we know that this portion right over here, that parabola is given in this way. And f of 1 equals 3. And then what is f value of f of negative 5? So in fact, this one can come from, in case of a, let me just write down the work over here. Since I'm comparing 1 and negative 5, my work can come from f of negative 5 to 1 of g of x, because g is the derivative. Then we know that this must be equal to f of 1 minus f of negative 5. You see, by the fundamental theorem of calculus. So this is the equation where I can get my answers from. So here we get integral from negative 5 to 1. Let's try to find the area. So you see the first area that we have over here. That's a square, 3 by 3. So that's equal to 9. But it's under the x-axis, it's going to be negative 9. Second portion, I'm going to look at this triangle here, 1 by 3. So we have 3 divided by 2, which is negative 1.5. And then next one here, that's the 1 by 2 divided by 2, so area is 1, positive 1. So then we get to realize that first portion becomes negative. From here to here, we get negative 9.5. And f of 1, they told us that it was equal to 3 minus f of negative 5. Then we get to realize that f of negative 5 must be equal to 3 plus 9.5, which is equal to 12.5. That becomes our first answer. Let's look at part B. They want us to evaluate from 1 through 6. Okay. Part B. 1 through 6, g of x dx. So then what I can do is 1 through 3 is simply a box. So I can rewrite this one as 1 through 3 of g of x dx plus 3 through 6 will be based upon this one. 2 times x minus 1, or 4 rather, square dx. So the first component, I know that it's a square, so I get 2 by 2, we get 4. That's the first one. How will I be able to integrate this one? Since the coefficient of x equals 1, we can just do this one quite easily. So we get 2/3 x minus 4 to the third power, you see? From 3 through 6. That's what I can do. Now, then when I plug in 6, this is 2, so 2 to the 3 power becomes 8. So we get 4 plus, we get 16 over 3. And when you plug in, not actually plus, but rather minus. When you plug in 3, so we get negative 1 to the third power, which is negative. But negative, that makes it into positive 2/3. So this one becomes 6. 4 total becomes 10. So that's the part B answer. Let's look at part C. From negative 5 to 6, all right, on the open interval, if any, is the graph f both increasing? F is increasing, that means g of x has to be greater than 0, positive. And concave up, that means g of x is increasing. So that's basically what I'm looking at. Where do I see g of x is positive above the x-axis? So then I'm looking at this section right over here. That's the above the x-axis. But concave up, it has to be concave up. That means that's concave increasing. Concave up, that means g of x is increasing. Stop and decreasing. Oh, right over here, it's increasing. So we have two intervals. That satisfies the answer. Whoops. So then, here, our answer will be 0 through 1. 0 through 1 is one interval, or second interval is 4 to 6. Those are the two intervals which we are looking at. And then the reasoning is increasing implies that derivative of f, which is g of x, has to be positive, and f is concave up. That means second derivative, which means the derivative of g of x has to be positive, meaning g of x is increasing. So that's basically what we can write to get the answers. All right, let's look at part D. Find the x-coordinate of each point, the point of inflection. Point of inflection is where second derivative concavity changes. Positive to negative or negative to positive. That implies, since g is the derivative of f, so that means g prime has to be positive to negative or negative to positive. So that means, what does this first one explains? G is increasing to decreasing or decreasing to increasing. That's basically what we're looking at. So where do you see G increasing and then all of a sudden decreasing? So increasing, and no, it stops. Increasing will stop. Oh, decreasing and increasing. Oh, wait a minute, right over here. You see when x equals 4, before x equals 4, G was what? Decreasing, implies that G prime was negative, which implies that F double prime is negative. So x equals 4 because when x was less than, or to be more precise, when x is less than 4 and then greater than 3, G prime was negative, which implies that F double prime is negative. And then when x is greater than 4 till 6, G prime was positive, which implies that F double prime is positive. So therefore, you have point of inflection at x equals 4. Alrighty, so with this one, we're going to finish up number 3.